Section 13.3, equilibrium constants. Go and check out video problems 71 and 72 when you're done with this video. You'll be doing a little bit of work with writing equilibrium expressions. Okay? So we talked about equilibrium in the last video, and we can set up this ratio of products compared to reactants, and when we do that, we have what's called an equilibrium constant expression. All right? Now K, this is your equilibrium constant, and the question is, how constant is that? Well, as it turns out, this value Kc will always be the same value at a given temperature. So it is temperature dependent. And you'll see that later on in this video, what I mean by temperature dependent. Okay? So what we do is we write the products over reactants, but we only use aqueous and gaseous reactants and products. If it's a solid or a liquid, it doesn't go in the equilibrium expression. Okay, and then we take the whatever the compound is, we take it to the power of its coefficient. So here you can see with this hydrogen and iodine one, the HI, the hydrogen iodide, has a coefficient of 2 in front of it, so we take it to the power of 2. Right? Now the C in this case stands for concentration. Alright, anytime you see square brackets, that means molarity, concentration as well. And it typically means the equilibrium molarity. Okay, so in other words, the molarity once we've reached equilibrium. Okay, so it's always products over reactants. You take it to the power of its coefficient. We only use aqueous and gaseous reactants and products. If it doesn't end in us, it's not for us. Okay, so here's where I let you know. Only gaseous and aqueous reactants and products. Alright, and again in the sample video problems we'll go through a couple of examples of writing it. And as I said before, the equilibrium constant for a reaction remains the same at a given temperature. That's where I'm telling you it is temperature dependent. Oops, that's still the highlighter. Okay, so here, take a look. We have 3 different experiments. Okay, in each experiment we're starting out with a different concentration, different concentration, different concentration. Actually, those are the equilibrium concentrations. Alright, but notice in each case Kc is equal to 54. So what happens is that while hydrogen, iodine, and HI are reaching equilibrium, the ratio is such that it will always equal 54, no units on an equilibrium expression, so long as the temperature is 427 degrees Celsius. If it's greater than 427 degrees Celsius, that Kc changes. If it's less than 427 degrees Celsius, the value for Kc changes. So that's what I'm saying when I say it's temperature dependent. We're not worried about being able to calculate if the temperature changes, right? So just realize that if the temperature changes, the K value changes. We'll talk about that more in AP.